We will now find the derivative, that is d2y by dx2 evaluated at x equal to 5. So basically this is the second derivative of the function y. It's the second derivative of y. So to determine this, we have to find the derivative of y first. Then we find the derivative of the result. So we have to basically find 2 times the derivative of y and then evaluate at x equal to 5. Then substitute the value of x in the second derivative equal to 5 and find the value. So let's see how to do this one. We have been given this function y equal to 6x power minus 3 plus 7x squared. So I'm going to find the derivative on both sides, or I apply the derivative on both sides. So I put the derivative symbol, that is d by dx of y on the left side. This is equal to d by dx of the expression on the right side, that is 6x power minus 3 plus 7x squared. Now the derivative of y with respect to x, this is equivalent to dy by dx, that is dy by dx is the expression for the derivative of y with respect to x. Now if you look at the right side, we have expression with the two terms. So here we can use the sum rule of derivative, that is, which says that if you have two terms, or if you have two functions, f of x plus g of x, and if you find the derivative, you can find the derivative of f of x, then sum it up with the derivative of g of x. So we can consider this expression as f of x and the second term as g of x. So I'm going to write down this using the sum rule. So I can put the derivative for both terms, that is d by dx of 6x power minus 3 plus d by dx of 7x squared. So I have applied the sum rule to write like this. Now I'm going to apply the constant multiple rule so that I can find the derivative of each of this term, because I can see that I have to have the constant in each of the terms. 6 is a constant in the first derivative and 7 is a constant in the second derivative. So according to this constant multiple rule, if you have to find the derivative of a function multiplied with the k, where k is a constant, you take the k in front of the derivative, that is you will not have to find the derivative of k. Instead you just have to find the derivative of the function and multiply with the constant k. So which means according to this rule, I can factor out the 6 out of the derivative, and similarly I can factor out the 7 out of the derivative. So therefore this becomes 6 times of d by dx of x power minus 3. So I write down like this, plus 7 times of d by dx of x squared. So it's basically we have to find the derivative of x power minus 3 in the first term and x squared in the second term. Let's do that. Here we can apply the power rule to find the derivative of x power minus 3 and x power x squared. So we have to use the power rule, which says that the derivative of x in the form of exponent, that is x raised to the power of n, this is equal to n x power n minus 1. So basically we put the n in front and reduce the power by 1 to the power of x. So let's do that. So therefore we can write down this as, this is 6 times of, I put the negative 3 in front, which is the power of x, and I put it as x raised to the power of negative 3, negative 1. I reduce the power by 1. And similarly, I have this constant 7, and then the exponent is 2. I put the 2 in front and then I reduce the power by 1. So therefore, I write down this as x raised to the power of 2 minus 1. So we can simplify this. 6 times of negative 3 is negative 18, and x raised to the power of minus 3 minus 1 is negative 4, plus 7 times of 2 is 14, and this is x raised to the power of 2 minus 1 is 1. So x power 1 is x. So we can simply write down this as 14x. So this is the first derivative of the function dy of the function y. Now let's find the second derivative, which means we have to find one more derivative. So we put the derivative symbol on both sides. So d by dx of dy by dx equals, so again we put the derivative symbol on both sides. So we are finding the derivative of negative 18x power negative 4 plus 14x. So once again, we have to go through the same rules. So first, let me write down this term on the left side. So the derivative of dy by dx is equivalent to d2y by dx squared. This is basically the second derivative of the function y. So here I'm going to apply the sum rule first. So I write down this as d by dx of negative 18x power minus 4, that is for the first term, and similarly I put the derivative symbol, that is d by dx of 14x. Once again, I see that I have some constants in each of those terms, so I'm factoring negative 18 from the first derivative and 14 from the second derivative. So therefore I can write down this as, when I use a constant multiple rule, I can put this as negative 18 times of d by dx of x power negative 4 plus 14 times of d by dx of just x. So basically we are finding the derivative of only the x power minus 4 in the first term and only the term x in the second term, because the constants we have factored out. So now let's simplify this. Now we can apply the power rule to find the derivative of x power minus 4, which means I have to put the power of the x, that is I put the negative 4 in front and reduce the power by 1. So therefore this becomes negative 4, negative 1 plus 14 times of, once again I apply the power rule for x. So you can imagine that x is equal to x raised to the power of 1, which means I put the power in front and reduce the power by 1. So therefore this becomes x raised to the power of 1 minus 1. Now this is equal to 18 times of 4, that is negative 18, negative 4 is positive 72 times of x raised to the power of minus 5 plus 14 times of 1 is 14, x raised to the power of 0. So in x raised to the power of 0 is equivalent to 1. So we can simply write down this as just 14. So we have this expression, we can put this in terms of positive powers of x. So I can rewrite this equation as 72 divided by x raised to the power of 5 plus 14. So this is basically the expression for the second derivative d2y by dx2. Now to answer the question, which is actually we have to find the second derivative evaluated at x equal to 5, which means we have the expression for the second derivative, and in this expression we replace x by 5. So we can write down this as in symbol notation as d2y by dx2 evaluated at x equal to 5. We write like this. This is equal to 72 over, we replace x by 5. So therefore this becomes 5 power 5 plus 14. And we can plug this into the calculator. When we do that, we get the value as 14.02304. So this is the value of the second derivative evaluated at x equal to 5.